Here I will tell you how the course is organized. Starting with the learning objectives, after the course you should number one, master the fundamental concepts and terminology used in computer architecture, understand the design principles of processors. You should understand also the design principles of memory hierarchies. Processors and memory hierarchies are the key fundamental concepts in building computer systems. Third, we will also expect that you will understand design principles of multi-core microprocessors, which are ubiquitous these days. And finally, cross-cutting all these different dimensions, you will be able to use state-of-the-art modeling methods to assess the impact design alternatives have on performance and energy. These methods are used in computer industry to assess, to tune software to run faster, to tune the hardware to make the software run faster, and also more energy efficiently. As for the course organization, it is consists of 7 lectures, pretty much one every week, and on top of that, starting this first week, I offer 2 optional crash course lectures on key concepts that you need to know about that you might not have dig deep into in your undergraduate studies. To really see how the concepts that you learn in computer architecture are used in state-of-the-art industrial products out there, you will go through what is called 2 sessions of real stuff presentations. So each participant, together with a fellow student, will will study a certain computer product and analyze what concepts have been used based on what we learn in this course, and do a 10-15 minutes presentation in the end in front of the other course participants. Also, every week, more or less, we organize a problem solution session in which you will actually focus on solving key problems in and using the learned concepts in realistic contexts. On top of that, starting from week 3 in the course until week 5, there is a laboratory session lasting for about 4 hours, in which you're gonna get assignments and do some small research studies, you could say, very guided studies, and write a report. I'm going to get back to that, that this is actually needed in order for passing the course. The lectures in this course are different from what you have met earlier, I suppose. So, as you have seen, I've taped all the lectures, so they are available on YouTube. And I expect that you have gone through the material when you come to a flipped classroom teaching session. So my way of doing lectures is to actually, assuming that you have at least an idea of the content, and that we use that to get on solving real problems, okay? So there's a lot of interaction. It will be driven by you, and your questions rather than me guessing what you need to know. A lot of interaction, active learning. So, preparation. Watch available YouTube lectures before class, and this will start next week. Okay? So, for the lecture on Monday, be prepared having watched the YouTube lecture online. There is a textbook that I follow blindly, and it's because I put a lot of devotion to writing it after many decades of experience in teaching this material, together with two colleagues at the University of Southern California, Michel Dubois and Morali Anavaram. This book is available for sale at Cremona. Only selected chapters of the book are used in this particular course, but let me tell you that also we use this book in two other courses, Parallel Computer Organization and Sustainable Computer Systems, that are especially for those of you who will follow the track in computer systems. The book is also available in the other courses, as I said, in the computer architecture track. As for the course contents, there are 7 lectures, as I already said. We are going to start with lecture 1 right after this video module. And this week, I will also offer, first week that is to say, 2 optional lectures. One is on the basics of modern processor design, especially pipelining concepts, and as a litmus test whether you should enjoy that or not. If you already know what the read after write hazard is, or delayed branch stalling, then you might not have any use for that, especially if you're a student at Chalmers, have taken the computer systems basic course in the undergraduate program. It's pretty much repeating those concepts, but you might have a faint memory of them, so why not going and listen. The other lecture, optional lecture 2, is about basics of memory hierarchies. We go through caches and interconnects. And litmus test again, do you know what a memory hierarchy is? What is a set associative cache? What is miss penalty? Well, if you don't know about those concepts, you should gladly entertain that lecture. And that actually takes us all to the same level, so we can move on with advanced pipelining techniques, advanced techniques to build cache hierarchies, etc., which will be taught in this course. The next 3 lectures is on techniques to exploit instruction level parallelism. We do that from different angles, starting off with static instruction scheduling, moving on to out-of-order execution, Thomas Zulu's algorithm, branch prediction, and this enables us to look at speculative execution, where we can really have hundreds of instructions in flight and let the compute engine actually figure out which of those can be executed independently without breaking any program correctness issues. Then lecture 5 is on memory hierarchy concepts, where we learn about new concepts to improve the performance of caches, inclusion, lookup free caches, prefetching, etc. And then lecture 6 is on multi-core architectures, where we'll learn about how to actually use parallelism to hide memory access latency in terms of multi-threaded architectures. We learn about how parallel programs can run correctly by supporting cached coherence. And then that's it. As for the course schedule, we use as all courses now do at Chalmers, we use Time Edit, which actually keeps track of the scheduling of all lectures, exercises and labs, and also course information used. So there are a lot of resources that I'm uploading as we are moving on at Canvas. So there is of course a course schedule, which is under the syllabus tab, and then a lot of course material under the files tab, where you can get access to the where the video lectures are, the flipped classroom material, slide decks for all the video lectures, exercises and solutions will be made available once we have had the exercises, and of course the laboratory PMs. It could happen that we slightly change the schedule or introduce more resources for you. So keep an eye on updates at Canvas. We will send out messages to you when there are important notices to be given. So Canvases are, you could say, meeting the lecture room, essentially, where you can get access to all the information, all updates on the course, etc. Now to the examination. There are two things that are needed for you to pass the course. One is to hand in and get approved all the written reports, the one for each lab that is needed. I will be also happy to give out bonus points. So at the start of each lecture, I will have a quiz based on the YouTube lectures, and if you get 3 correct quizzes, you actually get approved on 3 quizzes. You will get 4 bonus points for the exam to use for getting higher grades only, not for passing the exam. Real stuff studies, learn how principles are used in commercial machines. This is very important. So this is a mandatory thing. And finally, the written exam is typically on concepts and problem solving, follows pretty much the material, and I will give examples of old exams, of course. The date for this year's exam is October 28 in the afternoon. And what is very important is actually that the lecture slide decks, they define the scope of the exam. So you will find on the first very slide in each slide deck references to the book, so you can go and dig deeper there. We take it very seriously to deliver good courses at the Computer Engineering Division, Computer Science and Engineering Department. So we want to improve the course continuously. If there are small glitches, we better know about them right off, so we can fix it as we go. Any concern you may have, contact me, contact the TAs. But of course there will be a course evaluation in the end. So I'm soon going to announce who the course representatives are. And with that, we can end this module.